Okay, so we can get started with our revisions. So let us revise the redox reactions. So first thing first, we can discuss the oxidation numbers. Yeah, so the oxidation numbers. So the oxidation number, it simply shows the degree of oxidation or reduction. Yeah, so the important thing here is to understand how to calculate the oxidation number. So now, the major thing to take note of is that the oxidation number of oxygen, it's -2, and then the oxidation number of hydrogen, it's +1. Yeah, so these are the two main things we should know. Okay, and then for hydrogen, the exception is only if hydrogen is bonded to a metal. So like let's say we have sodium, so sodium and hydrogen. So in such a case, when this hydrogen is bonded to a metal, the oxidation number becomes -1. Yeah, so we can have magnesium, we can have any other metal, lithium, we can have copper. So like copper hydride, lithium hydride, this is sodium hydride. If it's magnesium, we can say magnesium hydride. So in such cases, oxidation number of hydrogen is -1. So now, how do you calculate the oxidation numbers? So we can have an example. So let us say we want to calculate the oxidation number of carbon in carbon dioxide. So what we are going to say is, we'll simply say the oxidation number of carbon, it's so that's what we want to calculate. We put X plus the oxidation number of oxygen, we know it is -2, and then we multiply the -2 with this cut, which is outside. So if there was 3, we could have multiplied by 3. So everything is equal to the power. So like the power here, it hasn't been given. So if the power is not given, we put everything is equal to 0. So meaning the power here, if there's nothing, if there's no charge, we put it's equal to 0. Yeah, so if we had like if we had like a negative, then we could have said it's equal to -1. If we had maybe -4 as the charge, then here we're going to say everything is equal to -4. Okay, so we can calculate from here. We'll say this will be it's going to be x minus 4 is equal to 0. So meaning x will be equal to +4. So this is the oxidation number of carbon. Yeah, so easy stuff here. So what if we have sodium, hydrogen, carbonate ion, and then want to calculate the oxidation number of carbon here. So what do? We're going to say, okay, like the oxidation number for hydrogen, we know it's negative, it's +1. For oxygen, we also know it's -2. And then this one, sodium, is a group 1 element. So all group 1 elements, the oxidation number is 1. And then all group 2 elements, the oxidation number is 2. Okay, so now let us calculate the oxidation number of carbon here. We're going to say the oxidation number of sodium there. Sodium, we know it is 1, it's in group 1, plus this hydrogen, the oxidation number, we know it's 1, plus carbon here, the oxidation number we don't know, that's what we want to find out. We put X, plus the oxidation number of oxygen, it's -2, and then we have a 3 outside, so -2 times 3, everything is equal to -1. So we can simplify and see what we get. We're going to have so this will be 1 plus 1 plus X minus, so 2 times 3, it is 6, everything is equal to -1. Yeah, so nothing complicated, negative and positive, it's negative. Yeah, so we are going to say 1 plus 1, it's 2, 2 minus 6, it's -4, so -4 is equal to -1, or X minus 4 is equal to -1. And then to make X the subject, we're going to say 4 minus 1. So the oxidation number of carbon in that Chi compound is 3. Yeah, so you don't have to think a lot here. Yeah, so that's on the oxidation number. Can we do another one? Okay, so let us try another example. So this example will come from it's a test question. Okay, so this is what we have. If you are given such a question where they say, in which of the following does nitrogen have an oxidation state of 4? So this oxidation state is just a way of confusing people. Yeah, so that is just oxidation number. Okay, so now so we have these options. So they want us to determine, like, where is nitrogen having an oxidation number of 4. So what you do here, we have a mega tip. Like, we're going to say you have to start finding the oxidation numbers of N. This N you are going to find in each compound till you find where this +4. Yeah, so that's what we do. So like, we're going to test with this one. What is the oxidation number of N, nitrogen, in this one? So this is I've forgotten the name of this acid. Okay, so let us calculate the oxidation number. If we find 4, then that will be our answer. So like, what we have is this. What we have, this acid. So to find the oxidation number, we're going to say, what is the oxidation number of hydrogen? The oxidation number of hydrogen, it's 1, +1, plus the oxidation number of nitrogen, we don't know. We're going to say X, plus the oxidation number of oxygen, it's 2. So we write 2, and then it has a 3 outside. Okay, so from here we simplify, and we don't have space, so what do we do? Okay, so let us create some space. So want to determine where is the oxidation number going to be 4. Okay, so here and I forgot to put is equal to, so we're going to say everything so remember, since there is no charge, then we're going to say everything will be equal to 0. Yeah, I'm sure you get this. So everything is equal to 0. So we're going to have 1 plus x plus 6. 2 times 3 is 6. So everything is equal to 0. So when you solve, so this is what I did. The oxidation number of hydrogen is 1, and then nitrogen we don't know, it's x. Oxygen is negative 2 times 3, and then everything is equal to 0. Yeah, so this 2 times 3 we get 6, and then we can collect like terms. Negative 6 plus 1 is negative 5. It goes to the other side. This is our answer. So this is not what we're looking for. Us want to find where oxidation number will be positive 4. Yeah, so but we have found 5, so meaning this one is not the answer. So we go to nitrate or nitrogen dioxide. We start calculating. So we're going to say oxidation number of nitrogen, that's what we're calculating. Oxygen negative 2, here positive 2, everything is equal to 0. Yeah, so from here 2 times 2, 4, and then the negatives, it's negative. Yeah, when it goes to the other side, I'm sure you're able to follow here. So the oxidation number of nitrogen in nitrogen dioxide, it's 4. So this is what we are looking for. So therefore the answer is B. So this B is the answer. So if the oxidation number here, if we found something like if we found 7, we could have said this is not the answer. We could have now gone to test this, you also test this, you also test that. So sometimes they can want you to waste a lot of your time, whereby the correct answer is per last. Yeah, so you just have to be fast and accurate. Sometimes if you are very fast, you can make a mistake here, and then you find an oxidation number of 7. You even okay, let me test the other ones. Yeah, so that's on the oxidation numbers. There's also this satanic question, what is the oxidation number of chromium in potassium dichromate? So this is potassium dichromate. So chromate is this, and then potassium. So di, you know, it means 2. So this means so this is just like a side lesson. So dichromate looks like this. So I wanted to write like a 2 here, 7, and then the valency, it's positive 2. So when we are writing the positive 2 which is on top, it goes down. Yeah, so that was just me trying to explain how dichromate is written. Yeah, I haven't done it well. So the question is, what is the oxidation number of chromium in dichromate? So here you just have to remember oxidation number of potassium. Potassium is in group 1, so you write 1 times this 2. plus chromium, we don't know the oxidation number, we put X. X will multiply the number which is there 2, and then the plus the oxidation number of oxygen -2 times 7. So this is what I'm saying, oxidation number 1 times 2. For chromium, X we don't know, and then it has a 2. Oxygen, the oxidation number is -2, and then we multiply the 7 outside there. From here you can follow. So this is the Megamind document, we're just using it as reference to revise. Okay, so the oxidation number is +6. You can follow. X times 2 is that, blah blah blah, we are done. Should also do this certain equation. So here whereby we have hydrates of water. So like we want to find the oxidation number of chromium in this compound. So some of these things, it's very hard to work them out. Yeah, but with experience you can that's when you get to know the shortcuts and everything. So here when you have such a thing, you can simply ignore this H2O. So we just focus on this part. Yeah, so and then one thing also to know is that the oxidation number of sulfate, it's -2. So where the sulfate, we can put -2, and then potassium, the oxidation number is +1. So we can find what's for chromium. Okay, so chromium, the oxidation number we don't know, wonder it's X. Potassium, we know it's 1 for the whole lot of sulfate. So here it's for the people who read the document. This was a challenge, like what happened here, what was the magic? So the whole lot of sulfate, the whole lot of it, the oxidation number is -2. So this is the -2 which I wrote, times this 2 here. So if this 2 was a 3, then we could have said times 3. So the whole lot of sulfate is -2. Yeah, that's the oxidation number. So some of these things you learn from experience. Okay, so the oxidation number of chromium 1, potassium it's hold on, the oxidation number of chromium is X, we don't know, potassium is 1, sulfate is -2, and then we multiply by 2, and then what's our power? So there's no power here, meaning you equate everything to 0. So this is how 3 was found. So there is this homework which few people attempted. Yeah, so I hope you take your time to go through. So you know whose line this is. The big deal, balancing redox reactions. So apabane, if you are reading this document while playing music, not even reduce, you just have to turn off the music, not even reducing the volume. So oxidation, this one, it's deadly. Okay, so I failed to draw this emoji. Yeah, but I'm sure you know this emoji. So you guys did you did your the lab safety. So this is poisonous. So balancing redox reactions, it's the main deal. So if you are playing music, you turn off the music. If you are eating dear Joby, you stop chewing. You just look for other ways and means to swallow, but thou shalt stop chewing. If you are dozing, thou shalt wake up. Yeah, so now we're going to the main business of the topic, redox reactions. Okay, so that will continue in the next video. So go and drink water as we revise together. Okay. Also, this was the other way we're using this board as well. Okay, so see you in the next video.